In this video, we're going to look at some geometry. Much of this is review, but it probably doesn't hurt to go over it. We're going to start with parallel lines and transversals. So let's start with a line to begin with, just to make sure we're all on the same page here. If I'm to start here and look at the angle that is formed as I move to here, hopefully you can realize that that's 180 degrees. So that's 180 degrees. So one straight line makes up 180 degrees. Now we need that in order to talk about supplementary angles. So supplementary angles are just two angles that add up to 180 degrees. So here's my straight line here along the bottom. And I've divided that line into two angles, one over here and one over here. Well, we already know that from here, let's try a different color on that. We already know that from here all the way over to here has to be 180 degrees. It's a straight line. So if I don't know what this angle is, and I don't know what this angle is, I do know for sure that those two angles have to add up to give 180 degrees. That's what we call, those are what we call supplementary angles. So any angles that make up a straight line have to add up to 180 degrees. So for example, if x was equal to 60, then we can find y because we would know that 60 plus y has to equal 180. And we could just solve that equation, subtract 60 from both sides, and we would get y is equal to 120 degrees. So that's what a supplementary angle is. Let's talk now a little bit about opposite angles. So opposite angles would be, say, this one right here and this one right here. And I've kind of exaggerated the line that stretches here so that you can kind of see. But it sure looks like these two angles are the same. And in fact, what the opposite angles tell us is that opposite angles are equal. So again, if I call this x and call this y, then what the opposite angles tell us is that x has to equal y, because those are opposite. They're opposite in that they make up the sort of opposite end of an x. So we can do the same thing over here. This angle here and this angle here are opposite angles. So if I call this A and B, say, then we know that A has to equal B. Now we have some abbreviations for these. So rather than talking about supplementary angles all the time, sometimes what we do here is just abbreviate this to the supplementary angle theorem, or SAT. Just saves us from having a whole mouthful or having to write a lot down. And same for this one. This is the opposite angle theorem. Opposite angle theorem, so the OAT. So that might save us a little bit. All right, so now that we've got some of the basics, oh, one more thing. Sorry, I forgot one thing. We'll just do it over here. And that has to do with triangles. Again, you probably know this already, but the angles inside a triangle, if we take all three of these angles, they all have to add up to 180 degrees. So A plus B plus C has to equal 180 degrees. Sorry, I put my equal sign on the wrong side. There we go. A plus B plus C has to equal 180 degrees. So that's what we call the angle sum theorem. So the angles in a triangle have to sum to 180 degrees. We'll look more later at what happens if it's not a triangle. But for right now, the angle sum theorem, angles in a triangle have to add to 180 degrees. All right, let's look at some parallel lines, which is really why we're here today. So parallel lines are two lines that continue on in the same direction. I'm not going to do a very good job of drawing parallel lines, so I'm going to get the line tool, and we'll pop a line here and another line over here, and hopefully they're parallel. All right, so those two lines are parallel. Typically you show parallel lines by having, whoops, not that, by having an arrow on either end of the line to indicate that it goes on forever. So that would indicate that this line goes on forever, and we could do the same thing here. And then we often show parallel lines by having some kind of, sometimes a double arrow like this to indicate that these two lines are parallel. Sometimes it'll show just as a single arrow. And it sort of depends on how many parallel lines you have. I'll get rid of that second set of markings just so that it doesn't mess us up too much. All right, so those are the lines. Here's what a transversal is. A transversal is just a line that cuts two or more parallel lines. So this would be our transversal. Whoops, whoops, whoops. Hang on, let's fix that up. Transversal. That's what this line here is. Alright, so this is the transversal. Again, it's a line. It goes on forever in either direction. And the reason why we want to talk about transversals is that there are some interesting properties here dealing with parallel lines and transversals. So let's see if we can grab another line. Not another set of lines, pardon me. We'll grab a set of parallel lines, and we'll look at what happens when a transversal crosses those two parallel lines. So we're going to talk about alternate angles. So alternate angles are angles that would happen on alternate sides of the transversal. So here's an angle right here. So when I say, hang on a second, that's not quite what I want. When I say alternate, they're on opposite sides of the transversal. So this angle's on the left side of the transversal, but they're also on sort of opposite parts. So here, this one angle's at the top. It's on the opposite side from this one, and it's also at the top. This one's at the bottom. So it's kind of opposite in both directions. So these are called alternate angles. And it turns out that alternate angles are equal. So if I had this as angle x and this as angle y, then x would equal y. We have sort of a another name for this theorem, or this alternate angles. We often call it a Z pattern because you can see if you trace it out here between the parallel lines down the transversal to the next parallel line, we get a nice looking Z. And I should mention that it doesn't matter if our Z is sideways, backwards, upside down, but we typically call this a Z pattern. And so that Z pattern can help us find missing angles. I'll try to draw another one in here. I know it's getting a little bit messy, but I'll try to draw the other one going the other way. So here's our Z going the opposite direction. We have alternate angles here and here. One's on the left, one's on the right, one's on the top, one's on the bottom. So I'll call this A and B. So this means that angle A has to equal angle B. All right, let's move on now to corresponding angles. So corresponding angles, again, we're going to draw our parallel lines and our transversal. Corresponding angles are angles that, for lack of a better word, correspond with each other. And what I mean by that is that they are on the same side of the transversal. So if I go on the left side here, I'm going to go on the left side here. And this one is below the parallel lines. So you can see that here's the parallel line. This angle is below the parallel line. So it's corresponding because this angle is going to be on the same side and below the angle here. And it turns out that corresponding angles are equal. So again, if I call this A and call this B, then we know that A is equal to B. And again, the easy way to remember that is we get this pattern that looks like an F. In fact, we call this the F pattern for short. So you can see here in green a bit of an F. And we can draw that F backwards. I'll draw it backwards in a different color. So we'll draw it this way. And you can see here that forms this angle and this angle, which are corresponding. I'll call them X and Y. So those two angles, X and Y, are equal to each other. And the last theorem here before we get to a couple of examples is the interior angle. So we'll grab a couple of parallel lines, draw in a transversal, and the interior angles are on the inside, meaning that they're between the two parallel lines. So for example, let me just grab my pen, change the color. This angle right here and this angle right here. Now this one's a little bit different. You can see that those two angles obviously aren't the same. The one at the bottom is acute, the one at the top is obtuse. So the interior angle is a little bit different, but let's call this A and let's call this B. It turns out that for interior angles, A plus B has to equal 180 degrees. So the interior angles have to add up to 180. And if we were trying to look for a pattern here, I'll try to draw this out. This one we call the C pattern. So this is what we call a C pattern. So for the C pattern, the angles add up to 180 degrees. This one we called the F pattern. Angles inside the F are equal. And we called this one the Z pattern. Angles inside the Z are equal. Now let's use that information to do a couple of examples. Find the indicated angles. So here we are. Here's example A. We'll start with something fairly simple. In fact, we'll start with just two lines that cross each other. Let's go this way. So let's call this X, and let's call this 45. Now, you might be wondering, why are we talking about parallel lines and there aren't parallel lines here? And this is just because I want you to think about some of the basics that we talked about earlier. If you're struggling, look for something that you know for sure. So for example, this right here is a straight line. What do the angles in a straight line have to add up to? Well, they have to add up to 180. That means that x plus 45 has to equal 180. So we can solve this equation by subtracting 45 from both sides. And when we do that, we get that x equals 135 degrees. So, and what I want to see, I want to see your work obviously, but I want to see what explanation you have for this statement here being true. Well, and this was true because this is a supplementary angle and we use the supplementary angle theorem. I don't expect you to write out supplementary angle theorem. I'm happy with you just writing out SAT for short. All right, let's look at a second example here. This one will have a couple of parallel lines. See if I can kind of make these parallel. There we go, somewhere around there. And we'll have a transversal coming down this way. Actually, you know what? I don't want a transversal. Let's do a line over here. And let's do another one over here. So I'm going to tell you that this angle in the top left-hand corner is 37 degrees. And I'm going to ask you to find a couple of other angles. I'm going to ask you to find this one right here and this one right here. Now I should mention these two lines are parallel. So I'll show that with the arrow. And these two lines going down here are parallel as well. So this one and this one. So indicate that those are parallel. So one of the things, and it doesn't necessarily matter what order you do these in, but one of the things that I notice here is that if I were to take a pen and draw an F, then I can see that I have some corresponding angles here. So we would say that x is equal to 37 degrees. And that's because of the F pattern. So the F pattern. All right, so we know that x is equal to 37. And now there are a couple of ways that we can find y. We could use the supplementary angle theorem to go from here to here. Or instead, if we wanted to, we could use the C pattern here, the interior angles. I'm going to use that one just because we talked about it, so let's have a look here. So because it's a C pattern, we know that x plus 37 has to equal 180. And then we can solve that equation by subtracting 37 from both sides. And when we do that, we get x on the left. 37 minus 37 is nothing. And then 180 minus 37 gives us 143. Oh, I'm sorry. I just realized that this should have been a y back here. Let's fix that up. Just go back and tidy that up. I said x plus 37. This is actually y. The angle in here was actually y. So I'm just going to change that to a y plus 37, which means that this should be a y as well. All right, so those are a couple of examples about how we can use some of the theorems to find angles. And again, we should state why. Like, what was it that allowed us to do this? So this was the C pattern. And I'm okay with you just writing C pat instead of C pattern. So I'm going to give you a chance to try these out and hopefully put them to good use.